So let's take a look at 5.3, section 5.3 once again. We're going to do some examples today. This is, again, we're going to talk about b to the 0th power and b to the negative nth power, and we're going to go through some examples. Take in mind, I guess, just a refresher again. There's b to the nth power is b times b times b times b, and we multiply it together n times because our exponent is n. Here's b. We got to remember what our exponent is and what the base is, what the exponent, I guess the fact that the exponent works on the base. We got to remember what the base is. So that in mind, let's fast forward through some of the stuff that we've done before, and now we take a look at some of the stuff that's going to be similar looking to one another, but just a little bit different, just enough different to say, let's think about things. So let's take a look at this. I'll do the first one, and you'll take a look. I guess we'll see that these three are all real similar looking, but you know what? They might have different outcomes based on what the base is and what the exponent is. So let's take a look at them. I'll do the first one. You guys can pause. You can pause at any time and kind of do your own work and then see what kind of answers I get as well. Let's take a look at 5x, and this is again in parentheses to the negative third power. That means that we've got negative third acting on our base. Our exponent is negative 3, base is 5x. So we take a look at, I guess just by definition, this would be 1 over 5x to the third power. If we reciprocate it, if we take the base, make the reciprocal, we can change the exponent to become a positive exponent. Then this becomes 1 to the third power as our numerator, and that would just be 1, or 1 to the third power. Our denominator is 5x as a base to the third power. And now we can just simply use the powers that we've learned before. This is 5 cubed, x cubed, and this would be 1 over 125, because 5 cubed is 125, x cubed is x cubed, and there's our answer. Go ahead and pause if you want and see what kind of answers you can come up with. So this one, if we take a look at our negative exponent, we've got again a negative exponent, but what's it working on? It's working on the base of just x. 5 is out front of it, so it's 5 times x to the negative third power. So this would be 5, stays in the numerator, over, we can take a shortcut and make it x cubed, and that would be our answer. If we go the long way, it would be 5 times 1 over x, and this would be cubed. This would be 5 times 1 over x cubed, and this would be 5 over 1 if you need. 5 over 1 times 1 over x cubed is 5 over x cubed, and that's the long way around. It's not really that pretty, so maybe let me rewrite it. 5 over x cubed is our answer, and this is just too sloppy to keep. So this 5 times x to the negative third power becomes 5 over x cubed, which is the same as 5 over x cubed. If we take the shortcut by making the x go to the other side, the base goes to the other side, and the negative 3 becomes positive 3, we can see that we can take the long way around by using our definition, and get to the same answer. Alright, what is this one? This next one is, again, similar enough looking, but what's the difference, I guess, between this one and this one? I guess there's only a positive sign here, or nothing, so we assume it's a positive sign, and there's an indicated negative sign right here. So what is the difference here? Well, this 5 times x to the negative third power, we took our shortcut and we said it's 5 over x cubed. Well, if this was 5, and this became 5 over here, this is negative 5, would stay negative 5 here, and this x to the negative third power, again, here's our exponent, working on the base of just x, becomes x to the third power on the bottom, on the denominator. So that negative 5 times x to the negative third power becomes negative 5 over x to the third power. And we can again go through our long way of using our definition of x to the negative third power would be 1 over x cubed. We could write it the same way here, and this positive 5 would just be negative 5 down here, and we keep the negative 5 here. This would stay the same, and then the negative sign would just be right here, and that would be our answer. So there's our answer. Alright, there's 3 that are similar. The next 3 as well look fairly similar as well. I would say take a look at some of these, maybe pause the video and see what kind of answers you can get without me working some of these. But let's take a look at some of these then. Alright, negative 4 is our exponent. It's a negative, and this is our base. So by definition, this would be 1 over 2w all to the 4th power. When you take the reciprocal of the base, you change the negative sign to positive in the exponent, and then we can just simply use other powers of rules of exponents to say that this is now the 2w to the 4th power. This would also be 1 to the 4th power. 1 to the 4th power is 1. So this stays 1. This is 2 to the 4th power times w to the 4th power. And this is 1 over 2 to the 4th power is 16 times w to the 4th power. And there's our answer. Alright, let's take a look at the next one. Similar again, but just a little bit different. So again, here's our exponent. It's a negative exponent. What's it working on? Working on just the w, because that's the base. So this becomes 2 times 1 over, let's use our definitions, I guess. 1 over w to the negative 4 equals 2 times negative 1, or sorry, 1 to the negative 4th power. Or sorry, this would be positive 4. Positive 4. When we reciprocate that w to make it 1 over w, the negative 4 becomes positive 4. Now this becomes 1 to the 4th power, or 1. W to the 4th power is w to the 4th power, and this is now, again, if you wanted to call 2 over 1, you could say now this is 2 times 1 is 2, 1 times w of 4 is w to the 4th power, and there's our answer. We could have also taken the shortcut of saying the w goes to the other side, and the negative 4 becomes positive, and the 2 stays in the numerator, and that would be our shortcut. Alright, let's take a look at this one. Similar to these two I guess are similar, but now what is different? I think the only difference is here's a positive sign, here's a negative sign. What would that be? Well, if this w to the negative 4th becomes w to the 4th power as a positive exponent in the denominator, then we can say that this would be just simply negative 2 over w to the 4th power. And that's again taking our shortcut by making the w go, the base, go to the opposite side of the divided by sign. Negative 4 becomes positive 4 in the denominator. And we've got our answer, negative 2 over w to the 4th power. Alright, how'd you do? Alright, well here is just simply a summary. This is now just a summary of what we've got for our rules of exponents. And I would say right now take a look at page 357 in the book. This is all copied from the book. A little bit small here, but again, this is going to be a take-home message. This is going to be something you can add to the study guide. And all these rules are just simply summaries, or I guess this table is an entire summary of everything we've learned in section 5.3. All right, let's do some examples in the next section.